Good day everyone. Welcome to today's video lecture on program simulation and code tracing or dry run as part of our preparation for the upcoming DICT ICT Proficiency Exam. Understanding how a program executes step by step is a crucial skill for any programmer. Through program simulation, we can mimic the execution of a program without actually running it on a computer. This allows us to analyze, test, and debug our code in a controlled environment before deployment. One essential technique for program simulation is code tracing, also known as a dry run. This involves manually going through a program line by line, tracking variable changes and understanding how different parts of the code interact. By doing so, we can identify logical errors and predict the program's output more effectively. In this session, we will discuss how systematically trace a program using dry run trace table, explore common pitfalls, and practice applying this technique to different code examples. These skills will not only help you in programming, but will also be valuable for answering problem-solving questions in the DICT ICT Proficiency Exam. So let's get started. So program simulation is the process of mimicking how a program runs without actually executing it on a real machine. This technique allows developers to analyze, test, and debug their code in a controlled environment before deployment. By manually following each step of the program's logic, we can better understand its flow, track how variables change, and identify logical errors. This method is especially useful in debugging, improving problem-solving skills, and preparing for coding assessments ng katulad ng DICT ICT Proficiency Exam. So mastering program simulation will help us become more efficient and analytical programmers. So what are the key uses of program simulation? Program simulation is a valuable technique used in various aspects of programming. Here are some of its key uses. One is testing and debugging. It helps identify logical errors before actual execution, allowing us to fix issues early in development. Algorithm validation. By simulating the program step by step, we can ensure that our logic is correct and produces the expected output. Performance analysis. The technique allows us to evaluate how program behaves under different conditions, such as varying inputs or system constraints. And lastly, for educational purposes. For beginners, program simulation is a great way to understand programming concepts by manually tracing how a program executes. By using program simulation effectively, we can improve code accuracy, ma-enhance yung problem-solving skills, at saka makapag-build ng strong foundation in programming. Why is program simulation important in programming? Here are the key reasons. 1. Debugging logical errors without running the program. So instead of executing the code immediately, pwede nating ma-analyze its flow and ma-identify yung mga errors before running it. Also, understanding control flow. It helps how loops, conditions, and functions work step by step, making it easier to follow the logic of a program. Program simulations also prepares for coding assessment and exam. So mastering program simulation is a great way to prepare for coding exams like the DICT ICT Proficiency Exam, as it helps in quickly analyzing code and predicting outputs accurately. By practicing program simulation, we become better at debugging, understanding program logic, and solving programming challenges more efficiently. Now let's move forward and apply these concepts. So we have here several ways to perform program simulation to better understand and test our code. Here are some common examples. Flowcharting and pseudocode. Bago tayo mag-create or magsulat ng actual code, we can use flowcharts and pseudocodes to visually simulate the program's logic. Another example is for code tracing. This involves manually executing each step of the program, tracking variables, values, and predicting the output. Pwede tayong gumamit ng trace table. Also, another example is using debuggers. Tools like GDB, Python debugger, or Visual Studio Debugger allow us to pause and step through the code, simulating execution in a controlled way. And lastly, virtual machines and emulators. These are used to simulate different hardware or software environments, helping us test applications across various systems. By applying these methods, we can analyze and refine our programs before actual execution, making debugging and development more efficient. Code tracing, dry run or manually simulating program execution. So what is code tracing? Code tracing is also known as a dry run. Is a technique where we manually go through a program step by step without actually running it on a computer. This method helps us analyze how the program executes, track variable changes, and check if the logic is correct. So by performing a dry run, we can understand how variables change at each step, making it easier to predict program behavior. It detects logic errors before running the program, helping us fix issues early. And it ensures the program produces the expected output, improving yung accuracy and debugging efficiency. So this technique is essential for building strong problem-solving skills and preparing for coding assessment like the DICT ICT Proficiency Exam. To effectively perform code tracing or dry run, we need to follow these steps. Number 1, write down variable names. Sulat natin yung lahat ng mga variables found in the code. List all variables used in the program so we can track their values. Second, follow the program's flow. Execute each line manually, updating the variable values as they change. Use a trace table. Keep a structured record of variable updates at each step for better visualization. And number 4, analyze conditions and loops. Observe how control structures like yung if statements and loops nakakaapekto sa program's execution. And lastly, verify output. You compare the expected output with the trace results to ensure accuracy. By following these steps, we can systematically trace any program, identify errors, and predict its output without running it on a computer. In this example, we have a given source code and main then with 2 loops, an inner loop and an outer loop, and then it will display an output. So your task is to determine what would be the output for this source code. So as part of the program simulation, the outer loop here, row starts at 5 and decrements down to 1. So decrementation, so pababa siya from 5, 4, 3, 2, 1. Then the row is greater than or equal to 1. This is the condition. So if it's true, then it will execute yung inner loop. So the inner loop, the call starts from the current value of row. Whatever the current value of row, yun yung value ng call. And then it decrements. So call minus minus. So meaning if it starts with 5, 5, 4, 3, 2, 1. So if it's true, then i-execute niya ang code na to sa loob. So but if it's false, then execute niya to. Then go back again to the top. Now, after the inner loop finishes, a new line or \n is printed to move to the next row. Paano to i-execute using a trace table? So given yung sa trace table, following the steps na ginamit, so you have to identify the variables and then the steps and then the possible output. So we will try this on how to use a trace table in solving this, the final output of this source code. Now for the trace table, so we will start with identifying the steps. So steps 1 to up to, depende sa loop. And then the variable row, we have the row as the outer loop. And then we have the condition. Row is greater than or equal to 1, which is our condition. And then we have an inner loop, which is call. And then the condition is call is greater than or equal to 1. Then from here, what would be the output? So let's start with number 1. For int, row equals to 5. So it assigns value 5 for the row. And then it will test the condition if 5 is greater than or equal to 1. So 5 is greater than or equal to 1. Yes, it's true. Then therefore, we have this next, execute nyo to. So for loop, after initializing, then i-test nyo yung logic. If it's true, then execute nyo to. Else, if it's false, then ma-end yung program. So in this case, this is true. So therefore, execute nyo to. So in this inner loop, call is equal to row. So whatever the value of row, yun din yung value ni column. So which is 5. So then we will test if 5 is greater than or equal to 1, then the result is true. So therefore, if it's true, ito naman, pag true siya, execute nyo to, %d, call, so printf. So therefore, lalabas yung value ng call, which is 5. So after this, babalik siya dito, call minus minus. So therefore, the column will now have 5 minus 1. Decrement siya. So nagiging 4. So test natin ulit, 5 is greater than equal to 4 is greater than equal to 1, then it's true. So therefore, it will print the value of call. So from here, with the previous value ng 5, mag-print siya ng 4. So magbabalik siya dito sa call minus 1 equals to 4 minus 1, it becomes 3. Test niya ulit, if 3 is greater than equal to 1, then it's true. So therefore, i-print niya yung value of call after this. So lalabas 3. So enter. From here, babalik siya ulit dito sa call minus minus. So therefore, the value now is 3 minus 1, nagiging 2. So test niya ulit ang logic. If 2 is greater than equal to 1, then true. Therefore, i-print niya lang ulit yung value ng call, which now becomes 2. So i-print niya to. After this ulit, babalik siya dito. So therefore, 2 minus 1, it becomes 1. So therefore, 1 is greater than equal to 1. Ang result nito is still true. So therefore, lalabas 5, 4, 3, 2. Then, yung value ng call, which is 1. So after this, babalik siya ulit dito. Call minus minus. So therefore, 1 minus 1, it becomes 0. Test nyo yung condition ulit if 0 is greater than or equal to 1. This time, 0 is not greater than or equal to 1, so therefore, it becomes false. If it's false, hindi niya na ito i-execute, but lalabas siya dito sa loop, it will print \n. So therefore, in this case, it will display or print a new line. So yun na. Create siya ng bagong linya. So dito sa ating output, nag-display siya ng 5, 4, 3, 2, 1, then bumaba yung cursor dito sa next line. So after this, row minus minus, so current value of row is 5, it becomes now 5 minus 1, then 4. So i-test nyo ulit, if 4 is greater than equal to 1, now it's true, then what will happen, the value, execute nitong sa loob. So call equals to row, therefore equals to the value of row. Now it's 4, so 4 is greater than equal to 1, execute nyo naman ulit tong inner loop, then becomes true. So therefore, i-print na yung 4. Babalik siya dito, equals to 4 minus 1. Decrement siya. So i-test niya if 3 is greater than or equal to 1. Then it's true. So lalabas yung 4. Then with 3. Tapos, babalik siya dito. So execute niya minus 1. Naging 2. So this 2 greater than or equal to 1. Yes, it's true. Then print niya ulit yung value ng call, which is 2. So here, 2 minus 1, naging 1. So 1 is greater than equal to 1. Still true. Then, i-print niya yung 4, 3, 2, then saka 1. After this, balik siya ulit dito. equals 1 minus 1, it becomes 0. So 0 greater than or equal to 1 is false. If it is false, pag test niya to false, hindi niya to pag-execute, then lalabas siya, then it will print backslash, it will print new line. So therefore dito lalabas yung 4, 3, 2, 1, then next line. So pagbalik niya dito sa taas ulit, what will be the value of row? That is row equals to 4 minus 1. So now it becomes 3. So if 3 is greater than or equal to 1, then it's true. So therefore, execute nito sa loob. Now the value of column now becomes the whatever the value of row. So nagiging 3. So i-test nyo ito. If 3 is greater than or equal to 1, yes, it's true. Then it will display 3. Babalik siya dito. 3 minus 1, nag-decrement siya. Now becomes 2. 2 greater than or equal to 1 becomes true. Then display niya yung value. So ulit, balik siya dito. 2 minus 1 equals to 1. So therefore 1 is greater than or equal to 1. Now becomes true. Then i-display niya 3, 2, 1. Here, equals 1 minus 1, it becomes 0. So i-test niya. If 0 is greater than or equal to 1, then it's false. So therefore, wala siyang execute. So pag false na, lalabas siya dito, it will create new line. So therefore, lalabas dito sa final output natin, we have 3, 2, then 1. So babalik siya dito ulit sa taas. Row equals to, current value of row is 3 minus 1, it becomes 2. So i-test niya ulit. If 2 is greater than or equal to 1, this is still true. So therefore, the value of our column is equal to the value of row with 2. So 2 greater than or equal to 1, then this is true. So therefore, i-display niya whatever the value of column, which is 2. Then, so this time, sa decrement niya, minus 1, so naging 1 siya. So 1 is greater than or equal to 1. Yes, it's true. Therefore, i-display niya yung 1. Balik siya dito ulit. True. 0 minus 1 minus 1, it becomes 0. So 0 is greater than or equal to 1. Now, this is false. So pag false, exit siya dito sa inner loop, i-print niya yung backslash n, it will print new line. So after printing the new line, balik siya dito ulit, row minus minus. So therefore, the current value of row is 2 minus 1. Now it becomes 1. So i-check niya, 1 is greater than equal to 1. Yes, it's true. Therefore, we'll copy the value of the row to assign to column. Now it becomes 1. So 1 is greater than equal to 1. Yes, it's true. Therefore, you print niyo yung 1. So next na loop is equal to 1 minus 1. Value niya is 0. So therefore, 0 is greater than equal to 1. Now, the result is false. So therefore, if it's false, exit siya sa loop, print yung backslash n, it will print new line. So pag new line, so here, nagprint siya ng 2 at saka 1. Dito, nagprint ng 1. And then dito na yung cursor. Pagbalik dito, akyat siya dito. Now, i-test niya if 0, if 1 minus 1, it becomes 0 yung value ng row. So i-test niya if 0 is greater than or equal to 1. Now, the result is false. So if it's false, then return 0, end na ng loop. So pag end na ng loop, stop na siya. So the final output now becomes 5, 4, 3, 2, 1, 4, 3, 2, 1, 3, 2, 1, 2, 1, and then 1. Now we have here in our first loop, meron tayong 5 na inner loops. In our second loop, nagkaroon ng 4. In the third loop, 3. In the fourth loop, 2. And the fifth loop, 1 na lang. So this is our dry run or trace table. So with this is now our final na output for that particular problem. So I do hope you understand the process of dry run and then trace table. For the key takeaways, the outer loop controls how many rows are printed. The inner loop prints numbers in decreasing order from 1 row to 1. And then the program follows a descending pattern forming a reversed right angled triangle. This dry run helps understand the nested loop execution, debugging, and improving logic building skills. What are the common mistakes in dry runs? One, usually nakakalimutan yung lines of codes. And then, incorrectly, na kamali tayo for updating variable values, misinterpreting loops and condition, and forgetting initial values of variables. Kung hindi na initialize yung value ng variable, somehow it would be 0 or it's a random number. So what are the tips for efficient program simulation? One, always initialize variables correctly. Carefully track changes at each step. Use pencil and paper for better clarity. And cross-check logic flow in complex conditions. Now, we have here the example or dry run activity for code tracing practice. Our objective is to perform a dry run of a given C program by manually simulating its execution step by step using a trace table. For our instruction, you list all variables, identify the variables used in the program, which is variable A and variable B, and track their values. Follow the program's flow by manually execute each line of code and update variable values accordingly. Use a trace table. Fill in the table as the loop executes. And lastly, you predict the output. So after completing the dry run, determine the final values or final output or the values of A and B. Then compare with the expected output. Now, what are the questions to answer if in answering this activity? So, what are the final values of A and B printed by printf? Did the values change as expected in each iteration? And how does the while loop affect variable updates? Programming isn't about what you know, it's about what you can figure out, according to Chris Payne in Learn to Program. This quote perfectly captures the essence of programming. It's not just about yung memorize mo yung syntax or functions. It's about problem solving, logical thinking, and continuous learning. As programmers, we won't always have all the answers. But by applying concepts like program simulation and code tracing, we develop the skills to analyze, debug, and improve our code efficiently. Let this mindset guide us as we explore more techniques to enhance our programming skills and prepare for the upcoming DICT ICT Proficiency Exam. Today, we explore program simulation and code tracing dry run. It's a powerful technique that helps us analyze, debug, and understand program flow without executing the code. These skills are essential for solving logic errors, improving problem-solving abilities, and ensuring accurate program execution. As you prepare for the DICT ICT Proficiency Exam, I encourage you to practice these concepts regularly. The more you apply dry runs and program simulations, the better you will become at predicting outputs, debugging efficiently, and writing error-free code. Keep practicing, stay curious, and embrace the problem-solving mindset. Good luck and happy coding!